Okay, good morning everyone. Welcome to the final day of Dreamforce. Thank you all for being here. When I saw I was scheduled at 10 a.m. on the final day, I wasn't sure whether it'd be me, myself, and I in a room, but apparently there are more hardcore people than I realized. So congratulations on making it A, to the end of Dreamforce, and B, making it to a morning session on the final day. So we're here today to talk about platform events and microservice-based architecture. My name is Paul Batterson. I'm a technical architect at Mavens. We are a healthcare and life sciences focused consultancy across the US and Europe. Always looking for good people, so if you're interested, come and find me afterwards. I'm a Salesforce MVP, and if you want to share love or abuse following this, at P. Batterson is where you can find me. If you're looking for the code repositories, I have links at the end, but I'm fairly consistent, so P. Batterson is also my GitHub name because naming things is hard. So, the reason I want to talk about platform events and about microservices and about all this kind of stuff is because in the 8 or so years I've worked with Salesforce, I've seen a dramatic shift. I'm also going to apologize because I have the Dreamforce cough. Anyone else have that here? Yeah, okay. I'll try not to cough down the microphone at you too much. So, in the 8 years I've been working with Salesforce, I've seen a dramatic shift from it being really used in kind of small, discrete areas within organizations to now being used at enterprise scale. And when I started off, really Salesforce was firstly used by the CRM. Most organizations start off with Sales Cloud. Salespeople want to sell more, sales managers want to see them selling more, and so it was kind of a small installation. And then eventually you might add service in there, you might add some marketing in there, but things started getting added, and an org started getting a bit more complex. How many apps do we have on the platform? Custom, standard apps. All of them use pretty much the same 4 objects, don't they? Anyone ever built an app that doesn't use the account object? Yeah. Everyone uses it, right? So we've got to be aware of these things. And then what happens is they go out and people install things from the App Exchange. So stuff that we might not even be able to have a control over, that our app innovation partners build, and they're great apps, but again, using the same objects, impacting our governor limits, impacting our org, and we've just got to be aware of that. We then have our admin friends going in and doing point and click stuff. And are there any admins in the room? Wow, we're always a couple. Okay, welcome. You're in a safe space. But as you know, it's a mainly dev-centric room. We know that our admin friends go in and do things like add validation rules, add workflows, add process builders, add flows, and don't tell us. And then unit test break, and it's our fault. Is it? So we've got to be aware of these things. Stuff like that happens. Orgs get bigger, these things occur. And then we go in and we write brilliant code, never has any bugs, everything works first time. But things get more complicated, okay? As you start to use an org at enterprise scale, I'm lucky enough to have worked with some of the biggest organizations, lucky, unlucky, depends on the time of day, to have worked with some really big organizations that have thousands of users in Salesforce orgs. Things just get complicated, What happens is we go away and we've got coordinated chaos. That's effectively what software development is it's humans going and telling a machine what to do and then throwing a bunch of this together, all of our understanding together, and saying, yeah, this will work. And so we have all of us going away in different teams, working on different apps, coding away, and we kind of just throw it all together in a blender. That is really what an SIT environment is, or an integration environment. It's everyone taking their code, throwing it together, running all the tests, sacrificing the goat, hoping that the moon's in the right phase, and everything running. That's what a lot of environments are like, especially with big organizations. So hands up here who's ever worked on a project in an org or is a developer within an org where you're not the only development team. There's someone else going, could be an in-source, could be an outsource. Right, a fair few of you there. For a lot of us as consulting partners, as much as we would love a company just to use us and us alone, we know there are other consulting partners in there, all doing their own thing. And so this all gets blended together, and then, we get the occasional bug. Things get found out because, everyone's using the account object, everyone's got something running in a trigger. Is there anyone in the room who doesn't use a trigger pattern, by the way? I ask this every year. Okay, guys, go away and learn how to use a trigger pattern, please. But that happens, things occur in the org, all this stuff occurs, we find bugs, we all like to believe we write bug-free code, but does anyone write bug-free code? Oh, come and see me afterwards for a job. So we have these things going on, and really what we're trying to do is take all these different puzzle pieces that have been developed by different people, sometimes in different languages, in different countries, with different understandings of the org, of its structure, and we're trying to put all these things together. And it's tough, right? That's what leads to just difficult times. So the only thing we can guarantee is that everything is going to change, nothing's going to stand still, okay? Not even within a project do we know that everything is going to stand still. I mean, hell, I've worked on so many projects where a client has said day one we want X and day two we want Y. Things change. That's fine. We need to be able to deal with that. That's what we're here for. And the way we need to start thinking about doing that is to decouple. So, excuse me, in that org structure we were looking at a minute ago, we have what's termed a monolith. Everyone here familiar with the term monolith? Anyone not familiar? I suppose it's probably the hand-raising question. So, a monolith is just really a big application, everything thrown into one. And it's the way that software used to be done. You'd buy a bigger server. Excuse me. 4 days at Dreamforce and you're dying. Okay, so, and what happens is, within this big monolithic application, typically you have a database layer. So we all have our database on Salesforce. You have some business logic layer, which might be workflow rules, could be Apex code and other things, and then you have your user interface layer, which is going to be a combination of probably some Visualforce still, probably some Lightning, some standard stuff as well. But on the left-hand side of this picture, you can see that we've got all of our apps doing all of their stuff and kind of intermingling. So it could be that we're doing some sort of reporting, HR, invoicing, ordering, could be sales, could be marketing. All of this stuff is just thrown in together, and a lot of it is overlapping. And that's quite dangerous for us. What we want to do, and what we've seen a lot of the big organizations in the world do, so Netflix, Amazon, Google, all of these companies, and Salesforce themselves, is start to break things out into microservices. And they do this by decoupling. And the way that works is that you say, we're going to take a certain business domain, certain functional area, and we're going to separate that out from all the others. And what's interesting here is that often when I talk about this to IT directors, CIOs, or other developers, it's like, well, we're on Salesforce. We can't really separate it out because everything's on the same platform. Well, that's not entirely true. We just have to know who's owning things. If we have an order object, who's owning that order object? Who's in charge of that? That's an area of business functionality you want to control. So we can start to look at separating these things out and trying to separate out the database, so understanding ownership of things, so who owns this object, who owns these fields, who can update them. We can start to separate out our logic layer because we don't want to have logic firing more times than it's needed. And from a user interface perspective, we should try and be consistent with our patterns, but do you know what? We probably want to separate out some of that as well, especially because different applications within an organization, particularly nowadays, some might be Lightning, some might be Visualforce, some might be something custom as well on top. And so we need a way for these to communicate. So if we're doing something on Heroku, that would be via REST APIs, or could be via a messaging queue. But how are we going to do that on Salesforce, and how do we make that easy to integrate? And more importantly, how do we ensure that we're getting visibility? The reason we're doing all of this is that we're applying our same principles from writing code to our architecture. And that's really important. When we look at object-oriented programming, has everyone heard of the law of Demeter or Demeter? I was debating with someone last night how we pronounce this. It was an American colleague, so we didn't agree. So the idea, obviously, object A can see object B can see object C, but A should not be able to pass through to C. Okay, that's what we want within our application. If we have our billing application, that might need to know who our user is so that it can invoice them because we all want to make money at the end of the day. But does it really need to know much more about them than perhaps their name, their address, any credit card details? Or should those credit card details actually be in the billing system itself? How do we separate this out? How do we avoid it so that if we want to interchange parts, we can do? So platform events are coming to our rescue here. Has anyone used platform events already? Well, a smattering of people, okay. If you'd have all come in here with your hands raised, I might as well have not bothered anymore, so it's good to that. So platform events are a fantastic new bit of kit, and effectively they are an enterprise messaging bus or a messaging queue or a messaging service, depending again on how you like the nomenclature, on the platform. And they were the GA from summer 17, I think, and they're just really, really good to use. So for those who haven't used them before, what happens is some event occurs, okay? It could be a user clicking a button, doing some touch interaction on a mobile device, whatever it could be. That then creates a message. And that message is really just like an envelope. We can put in there whatever we want. We can define the parameters that go in there. And this is really the key part of all of this, okay? This little envelope symbol is the most important symbol you are going to see. That is our contract. That's our interface. That defines what we're going to talk about, okay? So in the same way that I'm sure we all program properly and define interfaces and then program against those interfaces like we would do with our APIs, this is how our messaging works. So we can decouple the application, and it's this message that is passed between our different areas. And that helps those areas of those applications stay separate. So what happens is that message gets put into an inbox and accepted, and that's our queue. It sits there for a while until someone can pick it up. It then gets taken out, and we can then process it. And it could be processed on Heroku, which we'll see today. It could be processed by some Apex code. And going forward, it could be done by point and click options as well. And so I'm going to talk to you about a brand new organization today. You didn't realize on the final day of Dreamforce you'd come and see a new company launched. We're launching NetPix, no affiliation to Netflix or anyone else, okay? Just happens to look the same. And NetPix is going to be a brand new image sharing service because there's not enough image sharing social networks out there. And people are going to be able to upload images, and eventually we're going to allow them to do things like them, add social comments. But we're just going to start off as an organization, phase one, dealing with the groundwork. And what we really want to be able to do is follow a very simple user story. We want to have users for a start because all systems without users are just pointless. We need someone to be using our system. We then want to build them because we want to make money. All those venture capitalists that have invested in us expect some return. We then want to allow our users to upload images because despite the fact we're going to be the world's premier image as a service organization, we're going to get users to generate our content for us because, why would we do that? And then we're going to use Einstein to help classify those images. And so what we're going to see from our decoupled architecture is a series of different areas that don't need to interact in real time, but can be coordinated together so we can swap them out. So our user is going to register via communities. As they register, we're going to create an event that's going to be picked up by AppCloud. That event is then going to create a billing schedule record. You will see it is the least detailed billing record you have ever seen, but we don't need those two things to be tied together, okay? We don't need our billing to be done immediately once the user's been created, and we don't need our billing to know any more about the user than their record ID. We don't need a lot of information. We can read that information from our database. We're then going to allow our user to upload an image via the AppCloud. That's going to get stored on S3, and I've stolen the S3 SDK to do that for us. That's then going to, again, create a message on our message bus. That event is going to be picked up by Heroku, and Heroku is going to take our image, send it to Einstein. I keep on saying Watson, I mean Einstein. We're running out of famous scientists now. Send it to Einstein. Einstein Vision Service is going to classify it. It's then going to send those classifications back via a platform event, and we're going to classify our image, okay? Again, all of these are areas where if you think about how you're structuring your application, you can decouple it. None of these things need to be happening in real time, and these are all areas that we might want to swap out later on. So for example, with Einstein, of course we want to use Einstein. I'm using the general classifier. What if we want to go away and use a new classifier and phase that in gradually? We can do that now, because we don't need to have our message. We only have our message. We don't need to have a very, very tightly coupled contract. Same with billing. We move out and start using something like Zuora or Financial Force or one of the many other tools to do our billing and our invoicing. We can just change that piece, and our message still works. So, at this point, let's jump over to a demo. And the laptop loads. Okay, so what I want to start off by doing is showing you our new user event. So events, platform events look just like custom objects. Excuse me. They have exactly the same format. They have fields, they have relationships, they have some standard items. And the only difference that you'll see is that they've got the _E. So we have C for custom objects, X for external objects, for example, and we have E for events. Nice and simple. We've got the standard items here, so we've got created by and created date. We've got a replay ID, so that if we want to go back in time and replay our events from a certain point, we can do so. Again, nicely decoupled, so that if a system crashes or goes down somewhere or whatever, we can still replay from that point. And then I've just added a field here for the user ID. So what's going to happen is we're going to register a user, create this event, that's going to be picked up, and we're going to retrieve some information from that user ID, but really just create the billing schedule against it. And I can show you what that code looks like. So again, all this code will be available. So this is the standard registration controller. Who here has seen this before? Most people, okay. And what I've done is I've just added 3 lines of code here, so that when we know that we actually have a user registered, what we're going to do is we're going to create a new user event down on line 59. We're going to put the user ID on there, and then we're going to publish it. And so that's really the key difference, is rather than inserting a record, we publish it to be consumed. Okay? And then our trigger that we write to consume that event is, again, nice and simple. So to read platform events in Apex, you just create a trigger. It only works on after insert, of course, because you can't update an event, you can't do a before insert, can't do a delete, really. So we just have after insert, and all we do is for all of the users we get, we loop through them, get their user IDs, we select the account ID because it's community, so it's a person account in the background, and we go away and we create a billing schedule. And, you know, we're a nice startup. We give everyone 3 months worth of free stuff so they get hooked on our images. And then we're going to have the first billing date as start of the 4th month. Okay? Nice and simplistic code. So let's go and do this. So here's our community, and I'm going to click sign up. And so I'm going to be called Dreamforce Demo User. DF17PE demo. Let's hope that that's not taken. And we'll go for, oops. So this is literally just the standard setup you get. Standard registration controller. Okay. So we register in the background after it asks me if I want to keep the password. It goes away and it generates that user. So I'm just going to log in with our newly created user. And you can see it's going to load up my images. And there's one I've made earlier just in case, because, you know, this is a live demo. Who knows what's going to happen. So if we go back over to our org and we refresh our list of billing schedules, platform events are really quick as well. So just to segue off a second, as I've been testing this and working with it, I've been very impressed with the volume. Like, this thing's super quick. That was real time, effectively, right? Although you can use it to throttle an application and allow you to kind of deal with peaks and troughs in volume, for a lot of this stuff, it's effectively real time. So we have our new billing schedule, and you can see it's attached to our Dreamforce demo user, and it has a billing status. And that record has been created asynchronously, but more importantly, that area of the application is completely separate and decoupled from the actual creation of a new user. So if we want to swap this out later, because we're going to do billing in a different way, we can do so, and we don't need to go away and rewrite the entire login process, which is, you know, not exactly a fun job, is it? So we're now in the system, and what we want to do is we're going to upload an image. But let's have a look at the events that work for that. So I've got another platform event here called image upload. Again, we have 2 custom fields here. We have one which is the record ID. So what we're doing in the background is we're standing on the shoulders of giants and using the Amazon S3 SDK. For those who look at the code later on, you can install that package into your org. Gives you all of the connectivity that you need straight off the bat. So we have a record ID, which is the AWS S3 object we're attaching to in Salesforce so we can store our metadata. And then we have our S3 URL. That's the image URL so that we can send it to Einstein. Okay? And one of the interesting things we have to worry about is images don't upload as quickly as platform events fire. So when I was writing this and testing this, one of the things I found is that I'd be uploading an image, and I'd have created the event and sent it off to Heroku, and Heroku would have called Einstein, and all of that would have happened before Amazon had actually got my image. So platform events was too quick for me. So what I've got here is I've added a process builder that's going to call an invocable action. And so 1 hour after the image has been uploaded, because not every user is going to be using such a fast internet connection, we're going to call that invocable action, and that invocable action is going to create our platform event for us. It's really interesting to show you this as well, because it, again, helps you think about how you could help your admin and functional colleagues to start using platform events. So you don't have to go away and write the code all the time. You can make it simple for them to publish. So you can just write the invocable action. And so the invocable action, quite simply, is this event here. So takes in our list of S3 objects, so that's the custom object where we're storing kind of the header information, and it loops through them, and it's just going to populate the 2 fields we need. So we have the S3 URL, obviously, because to classify an image, you need to be able to find the image. And then we have the record ID, because when we get the classifications back, excuse me, we want to be able to save them against that record. Otherwise, what's the point of classifying if we don't save the data? And as you can see here, I have a demo time method, because who here wants to wait an hour? Anyone got an hour free this morning? We can wait for it? I think we'll just do it. So let's go back over here, and we're going to upload a new image, and we're going to call this df17 demo duck. And I've got buckets here, so we can choose different buckets if we want to, and it will still work. I'm going to upload a PNG. And we're going to choose our white duck. And that's going to be uploaded. Okay, and as you can see here, everyone agree that that is a duck? If it looks like a duck, sounds like a duck, walks like a duck, it's a duck. So in the background, we've generated we've linked into that process builder, but what we're going to do is, because this is a live demo, we're going to go to our S3 objects, and we're just going to, this is one I was using earlier because, demos. And we can see number 37, we have here our image, df17 demo duck, and I'm going to copy this ID. I'm going to go over to the developer console, and I'm going to tell it to start listening again. And we're just going to tell it to go to Heroku and do that work for us. So in the background, that is going to just publish that platform event that we saw in that invocable action. And that's going to go over to Heroku. So how do we consume these events off platform? One of the real reasons we want to use platform events or any messaging queue is to allow us to do things elsewhere that we either can't do in a scalable manner on Salesforce or can use a tool that's slightly better for them. So we're using Heroku here because calling out to Einstein is quite nice and easy. There's an Einstein Vision plugin that's on Heroku that's really cool and easy to use. Plus, it's just a good demo. So what I've done is I've stood on the shoulders of giants again, and if you go and look at the Einstein Vision node example, you will find all of the lib file here, all of the lib directory. You'll probably find a few extra things as well they've got in there, but I've pared all this down, and I'm not going to go through that code because it is just generating the tokens. That's just code that Salesforce has provided to make things easier. What I will do, though, is go through this part. So we're just starting up an application. We've got a few libraries we're including. JSForce is going to help us to listen out. And we're going to start our app, and then we're going to log in using JSForce. So has anyone here used JSForce or NForce or any of these other things before? Okay. So really simple, great library for JavaScript with Salesforce. But what's important is this line here, line 22. So for us to listen out for platform events, what we have to do is we have to subscribe to their streaming channel. And this is, quite honestly, one of the best decisions that Salesforce have made around this, is that for you to be able to consume platform events in any other system that isn't Salesforce, you just use the streaming API. That's very nice and very simple because all of the existing integration toolkits make the streaming API available. You just have to make sure you're using the latest API version. But it's really quick and easy for us to then be able to work with them. Okay? And it means that you can listen out using Comet D, you can listen out in the browser, you can listen out on Node.js, in Java, or whatever else you want to use. And it's just easy to integrate. And so we listen out, and when we get a message, we then send that to Einstein. So this is, again, some pre-canned code. And we're going to get back a set of predictions. So this line 32. So we get our predictions back. We're using promises because we don't like callback hell. And so what we do is we take our predictions, and we're just going to go through all of the classifications because we don't know how many we're going to get. And for each of them, we're going to create an image classification event. And we're just going to publish that back by inserting it. So for us to be able to create them on platform, we publish them. For us to be able to create them off platform, we just insert them as we would do a regular S object. Really, really simple and easy to integrate with. Okay? And then we just debug that all out if we want to see that. So this code is all up online, so you can run this locally on your own machine if you want to. And it makes it nice and easy for you to be able to see the classifications coming back and things like that. And let's just jump back over here, and let's see the classification event that's coming back. So what comes back is we have a particular classification. So that is a label. So that might be, so we've uploaded a duck, so it might be goose or something like that. I don't know. Hopefully it will be duck, but we'll see. We're using the general classifier, so we don't know. We're going to have the confidence level. So that is a percentage in a decimal format. So something like 0.7 or whatever. And then we have the record ID that we can attach the classification to. And what we're going to do is we're going to pick that up again with a trigger. And as that comes in, we're going to create a classification record. Classification record literally stores the label, the confidence, and it stores it against our S3 object, okay? Very nice and simple. So again, why have we chosen this to decouple? Well, what happens if we want to use a different image classifier? We've still got our two events that are fine. We can just pass back the data in the updated format we need. Everything's nice and easy for us to decouple. So hopefully, we've given it a bit of time for all this to connect together in the background. And when we view our object now, if we refresh, live demo has worked. Thursday morning, you never know. And you can see down the bottom there, I don't know if it's big enough. Let's just zoom in. But we've got a set of classifications it's come back with. So there's a 56% chance that this is an American egret. So, fun side story, there's no word for egret in British English. I had to find out that that was a heron. Genuinely, the first time it came back, I was like, what is this all about? A goose, I could see why it comes back with a goose, that's 29%. There is also a 1% chance that this is an albatross. So, you know, we might need to work on our classifier in the background, but, you know, that's why we've got our data science team. But all of that happened asynchronously, nice and quickly for us, really easy to use. Okay? So I just want to wrap up now by jumping back to the presentation. And telling you some of the reasons I think this is really, really important and worthwhile. So I have built, a couple of years ago, I actually did another microservices talk at Dreamforce. So, you know, there's a pattern here. Guess what I'm going to be talking about next year? But we were using REST APIs and AMQP to coordinate that off-platform. And it helped us to, again, build decoupled applications because, yeah, we have some users that wanted these big applications broken up. But platform events makes things 10 times easier. And if I was to give you 3 reasons why you should start looking at this, the first of them is going to be cleaner code. So I am going to put my hands up and say that the code in that repository is not going to be the prettiest code you'll have ever seen. I'm also going to caveat that by saying very little of it is mine. So, but the actual code to do the connectivity part there is really quick and easy. And it also means that we can have our code separated by our business logic, by our business function, by our business domain, so that we can start to program properly. So that we don't have to worry about having lots of different overlaps and lots of different pieces kind of coordinating together. We've all written triggers where we've had to put in catch statements at the top to check whether or not we've run 3 times already or not. And so just from that perspective, it's nice and easy. I also wrote a blog post a month or 2 ago where you can consume platform events in Node.js on Heroku in 10 lines of code. That's it, 10 lines of code. That obviously assumes you're not using the Einstein Vision piece and all that, but if you want to, that's how quick and easy it is to consume these events off platform. So your code's gonna be a lot cleaner and easier. It's gonna be much easier for you to structure it and put it together. That's gonna make it much easier to collaborate. If you are working in a large org where there's lots of teams going on, you need to be able to work together properly. And this just makes that a ton easier because your two teams can go away and build their things, and as long as you've agreed that contract in the middle and that doesn't change, great, you can go away and work at your own paces. You can go away and do your own things. And that's really important as well because in these larger orgs and in these larger companies, different teams have different maturities, okay? Someone like the CRM team in a typical organization has been using Salesforce for years and years. Whereas someone coming in and maybe doing something new with, I don't know, with Einstein Vision or with DMP or Marketing Cloud or Commerce Cloud, that is probably less mature. And so they're going to be innovating and delivering at a different pace. And so you need to be able to collaborate together nicely, but you need to be able to make sure you can do that without being at each other's throats. And finally is scalability. And scalability is a two-pronged piece. Number one, it is scalability in terms of performance, because that Heroku app we've got there, I've got that running on a single dyno, and I'm obviously just doing demo work, but if we want to scale that Heroku app up to be able to do that more effectively, we can do so. That's something that's within our control. On Salesforce, we get a limited number of callouts per day, whereas on Heroku, that's our choice. So it allows us to be able to scale our applications more effectively by using the correct tools for the job at the right time. I also think it helps us with scalability because it allows us to deliver more. And going back to that point a second ago around collaboration, is when you look at maturity and you look at teams being able to come in and do new things, one of the things that slows a lot of big organizations down is that blender moment, is having to get together, take all the pieces, run all the integration tests. If you're in a validated environment, that can take longer as well. Whereas if you've decoupled your application properly, the different teams can go away and they can work on their stuff. And as long as that contract stays the same and is agreed upon, it's easy for you to work together. And so I'd just like to finish by saying thank you very much for coming. I hope this has been worthwhile you staying for the fourth day. There are the two sets of code there. If you have any questions on them, feel free to post up issues. But if you have any questions now, happily take them. Please come up to the microphone, though, as well. So if you can come up to the microphone, then people can hear it because they're recording audio. So thank you.
I know Salesforce, this is loud.
Yeah.
Salesforce already has outbound messages. If you have an external consumer, can you make any comments on when you would use platform events over when you would use outbound messages?
Yeah, sure. So outbound messages are for making SOAP-based call-outs to external systems. Platform events are for really coordinating two separate bits of logic. So if I've got an external system where they have a SOAP API endpoint and I want to use outbound messages to do something set, outbound messaging is a great use case there. If I'm building a separate application off platform and I'm in control of that and there might be some change within that application because I'm actively developing it, platform events would be a much better use case there. And then obviously there's that big gray area in the middle where you decide which one is in there. But typically outbound messaging endpoints tend to be very fixed and you tend to, I'd say, be integrating with an external provider that has that preset. Whereas a lot of platform event stuff will be more coordination with changing applications.
And I believe also that the outbound call can't store the limit while it's just a platform event. This is the consumer who comes to it and it doesn't count towards the outbound.
Yes, so that's a good point there. So platform events don't count towards outbound request limits, whereas outbound messages do.
Yeah, hi. Sorry, I'm new to Salesforce, so the answer might be obvious, but in complex event processing, in event-driven architecture, I worry that the traceability would be somewhat obfuscated when you're running into problems. Like, how do you trace where messages are flowing through the system and what's executing?
Yep, great question. So in platform events, at the bottom of each event, you can see there's a list of who's subscribed, who's processed, and the last processed ID, I think it is. Now, this is where I would go and check the documentation because I have a terrible memory for these things. But platform events are stored for a certain amount of time, so you can see that. Because it's queryable, you can have that output into logs. You've obviously got the created by ID and the created by date, so you can view them there. And you define the messaging contract. So if you want to add extra debug and logging information in there that you are then capturing and putting out, you can feel free to do that. So, and you can replay as well. That replay ID is that there was a use case I was talking to someone about the other day where if a system goes down and you need, for some reason it crashes and 20 events don't get done, you can just say, start from here, and it will go away and process those last 20. And so obviously there's a big point about idempotence there and making sure you structure things correctly, but that would be how you do that.
I was at a platform event session earlier this week. Essentially, what that person was saying was, I still need to validate this, but the guaranteed message delivery that's built in as part of the platform events, it's guaranteed to be delivered in 24 hours. And also the messages are persisted only for 24 hours, right? So if you build an architecture like this and you don't really have, like most service buses in the industry have guaranteed delivery, right? And it's definitely not 24 hours. And you can also persist the messages much longer. So don't you feel there's still some limitations around building this kind of an architecture, like an asynchronous, with an asynchronous paradigm, right?
This is for coordinating, so yes, there is, so first of all, this is the first real GA release of this, so, I didn't have a safe harbor slide, I know nothing, but, Salesforce are probably going to make updates to a brand new product they've released. If you are doing things that you think are going to take longer than 24 hours, platform events probably aren't the right tool for you because you should be thinking about batch processing then, or different integration patterns. I think the way I would look at this is it's another integration toolkit option. So all of the examples we've seen here today are things where we are expecting them to run, we'd like them to run in real time. They're not really going to run in real time because we don't need them to, but they're not big problems. So if I was going through and processing, 100,000 invoice lines to do billing, that's a batch process job. That's something you should be doing in a different methodology. And I think that's a key part here is understanding the different integration patterns. So Salesforce have a lot of information out there in the, someone's going to correct me with the integration, and I'm looking at Chris because he probably knows the name, integration designer, integration architecture designer. Yeah, there's an integration designer exam which covers in great detail all the different patterns that are out there. This is just a message bus. This is just one of the many patterns you could
still
use.
Need some more work, I think, before we can fully call it a message bus. But that's okay. So the other question I have is, did you define and create your microservices in S3? You did not create them in Salesforce, did you?
Sorry, did I?
Like the microservices.
No, my microservices are all in Salesforce. Everything was running on platform though. The only thing we were using S3 for was for storing images because, I wasn't sure how many times I'd need to upload a duck to test my code.
Okay. Okay. Thank you.
S3 is a good way, isn't it? No worries.
Yes. Outbound messaging was mentioned, and that this wasn't necessarily a good fit for it. Assume that perhaps you're using outbound messaging to kick off workflow in another type of application, and what you want is to subscribe to the status of different things that happen in the workflow in another application. Would seem to me that platform events might be a good way of receiving those updates.
It could be, yeah. So again, this goes back to, and this is only in my experience. In my experience, outbound messaging is mainly used for very going to say heavy, integrations with something
Right.
very heavy. So typically I've used outbound messaging when I'm integrating with something that's been built in .NET or Java. It's a
Right.
product that's owned and managed by someone else, and I'm just using it to send data across.
Right.
So SAP, the example that probably pops into everyone's head. A lot of those systems will give you then a status ID back that you might be able to work with. If you have control over the system, that could be a great way of doing it. And I think that's really one of the key things here is that when you
Yeah,
look
you
at
might send them a session ID so that they can go get your record and that type of thing.
Exactly. And I think one of the interesting things around these integration patterns, the point with that is that Salesforce are extending out our toolkit here of what we could do. I would probably not use platform events unless I was writing the code or I was working with another set of developers who were writing the code. If I was working, if we were working with another consultancy in an organization, it's a great way for us to decouple our pieces and to provide scalability. If I was working in an organization where we were integrating something where they had a SOAP endpoint, then outbound messaging is probably the better way to go for that. So I think of it definitely as kind of another, it's adding on a knife to the Swiss Army knife that we've got.
Exactly. Thank you.
All right.
Hi, I've got a question about limits.
Yes.
As always.
If you're looking up on your phone what the limit is and about to quiz me, this isn't going to end well.
No. So it says the maximum number of event notifications published per hour is 100,000 on unlimited editions.
On unlimited edition?
Performance Unlimited Enterprise.
Yeah. Is that the standard volume or the high volume?
I'm not sure, but that seems to be. Well, and then the next one, the line says the maximum number of event notifications delivered to Comet D clients within a 24-hour period is 50,000. Mm-hmm. So to me, that implies you can put 100,000 messages in, but you can only listen to 50,000?
So that's if you're using Comet D subscribers, which means you're typically using a streaming API subscription. Okay. If you're on Salesforce and listening on triggers, you're not using Comet D.
Okay, great. Thank you.
Okay, any more for any more? If not, I'll be outside afterwards. So thank you very much for coming and fill out the survey. Thank you.